Hey everybody, I'm going to try to do a video lesson while I'm a little sick, so try to bear with me. And sorry if this is boring, this would be more interesting if I was there in person, but we'll do our best. So what we're doing today is an introduction to this unit. This is the expressions unit, and I'm going to give you some instructions for the activities that we're about to do, so do your best to follow along. The first thing that I want to do is talk about the difference between expressions and equations. Here are some examples of expressions, and here are some examples of equations. Let's start by coming up with some things that they have in common. So in the double bubble map below, can you list something that you see in both columns? You could pause the video if you want more time to think. An example I see in both columns would be numbers. They both have 3s, 6s, 8s, anything like that. I see those in both expressions and equations. See if you can come up with two more. Pause the video, come up with two more things, then unpause the video when you're ready to check. You might have came up with some great ideas, but here are some of the more common answers I've seen for this sort of question. They both have variables. So an expression or an equation can have a variable. And then one other thing that they both have is operations. And if you came up with other ideas, that's okay too. Operations would be things like plus, minus, times, multiply, times and divide, sorry. How about what they have not in common? What's the difference? Do you see something that equations have that expressions don't? Pause the video, come up with as many of these as you can think of. Unpause it when you're ready to check. All right, hopefully you've paused the video and you've already had your answers. So the main thing actually that equations have that expressions don't have would be an equal sign. So an equation by definition has an equal sign. That's why it's called an equation. An expression has no equal sign. An expression, therefore, can't really be solved. For an equation, it actually has an answer that you could solve. You could find what that missing piece is. So equations, I would say that you could solve them. Expressions, you can maybe simplify them, manipulate the numbers around, but you can't find a final answer. And then therefore, equations have answers where expressions don't necessarily have like a numerical answer. And if you have different thoughts for your double bubble map, that's fine. Here's just a summary of what I usually see. Now I'm going to go through some vocab, and I'd like you to fill in the blanks on yours while I go through the vocab words. To make this a little bit more interesting, as I read the sentence, try to predict what I'm going to say in the blank. See if you could read my mind. It's okay if you don't come up with exactly what I'm about to say because you haven't learned this yet. And there could be multiple things that fit in the blank, but see if you could read my mind. An equation is a math sentence that states two quantities are equal. Again, that's where we get the beginning of the word equation. It will have an equal sign. If you said answer, you were still on the right track. An expression is a math phrase with at least one operation. So that's the plus, minus, times, divide. It does not have an equal sign. So think about an equation as a math sentence. Compare that to an expression, which is a math phrase. So an equation is a more complete thought. An expression is like part of that. This unit, we're just focusing on expressions. We're doing equations during our next unit. All right, I just plugged my iPad in. My battery percentage was making me nervous. All right, variable. A variable is a letter. Oops, better lock that screen. Still in highlighter. Letter or a symbol, did you guess it, that represents a value. Name the variables in the following expression. So what I want you to do is look through that expression, and any letters that you see, list them out in the variables. If you see a letter more than once, write it more than once. Go ahead, pause the video, write those out, and then unpause it when you're ready to check. All right, so you should see K, M, N, P, P. Take a look at my amazing meme here. What do you think it represents? Pause the video to think about that, and then unpause it when you're ready to talk. Well, surprise, I'm not actually going to make you talk. I'll do the talking. So you could see that the kind of casual, boring Winnie the Pooh, he has this little X here. The fancier Winnie the Pooh has a dot, and the fanciest Winnie the Pooh has nothing. And this represents the different ways we use multiplication symbols as we get into more grown-up professional math. So we used to write something like 3x2 to mean 3 times 2. And then you got a little fancier and you'd write 3.2 to represent the same thing. Now that we are even fancier, you know that you could do it like this. Or what you're about to see is with variables, if I'm multiplying something like 3 times m, oops, was that one of my examples here? Okay, I have 2k. I want to use 2k as my example. That is the same thing as saying 2 times k. But since we're the fanciest Winnie the Pooh, we just say 2k. We don't even bother putting the dot there anymore. We're so fancy. So variables could be anything that represents a value. That means that you could use a heart, you could use a smiley face, you could use the first letter of your name, whatever you like to represent a value, that works. We don't really use X anymore as a multiplication symbol. We just use it as a variable. And then be careful when you're writing things like T. That kind of looks like a plus sign, but you could write like a little curly T. Same thing with like an L versus a 1. Just be careful with that. So make them maybe look a little bit different. All right, coefficient. So remember, we're back to seeing if you could read my mind now. A coefficient is the number of times the variable is repeated. The coefficient is written before the variable. If I'm going too fast, feel free to pause. Every variable has a coefficient. Did you guess that all three of those would be the same? That's a hard one. So a coefficient is the number that's in front of the variable. Let's look at some examples. So we just looked at one, what was it, 2k? Yeah, we just looked at one that was 2k. What this means is k plus k. Instead of writing k plus k, we just write it as 2k. So 2 is the coefficient. If I said, what is the coefficient? You would say 2. What do you think the coefficient is for 5x? It would be 5. So 5x means this. X added together 5 times. It works the same way for negatives. So negative 3n, the coefficient is negative 3. So that's like saying negative n plus negative n plus negative n. That's the same thing. Another part of this definition that we just wrote is that every variable has a coefficient. So even if you see something like this, like p, it doesn't have a number in front of it. How many times is there a p? Oh, Miss Saban just texted me. Hi, Miss Saban. Maybe you are in Miss Saban's class with me right now. In front of the p, there's no number here. There's an invisible 1. We're saying there's only one p. So if they don't write it, it's a 1. Same thing here. If it was a j, the coefficient is still 1 even though they didn't write it. And it works the same with negatives. So if it was negative W, it would be a -1. Coefficients are usually the hardest vocab word for people to figure out. So if you're not fully understanding it, that's okay. We're going to practice it more. Let's look at this example. Name the coefficients in the following expression. First thing that we're going to do here is our bubbles. This is what's going to help us find the coefficients. We know how to do our bubbles. You bubble the first term, and then after that, you bubble the symbol with whatever follows it. So make your bubbles look like mine. Pause the video if you think that you can name the coefficients on your own now, and if you're not sure what to do, keep watching. All right, so part of the definition is that it has to have a variable. Remember how we wrote the word variable 3 times? So in order for it to have a coefficient, it has to have a variable. So I'm going to look through my bubbles and cross out any bubbles that don't have a variable, because then they wouldn't have a coefficient. So 15's got to go. -3's got to go. 0.5's got to go. All right. Part of our definition was that every variable has a coefficient. So what we're going to do now is look at each of these bubbles, and each one of these has to have a coefficient. If you think that you're good to go now in listing out the coefficients, pause the video and try it on your own. If you're still not sure, keep watching. All right, on my first one, 2k. This means that there are 2 k's, k plus k, so my coefficient is 2. That's the first answer, 2. Next is m. It doesn't have a number. That means there's just a single m. So the coefficient is 1. Same with n, 1. For -7p, what do you think it's going to be? Hopefully you said -7. I'm not going to write out all these p's, but it would look like this, but you would have like 7 of them. So each time they're a negative. What do you think about -p? -1. I'm going to copy down the rest of these answers. 2, 1, 1, -7, and -1. All right. Constant. See if you can guess what this word is going to be. A constant is a number with no variable attached. Think about what constant means. Constant means not changing. So 5 is always 5. That's different than a variable. A variable varies. X might equal 6 today, and in tomorrow's work, it might equal 7. But 5 is constant. It can only equal 5. So go through again and find the constants. Bubble your terms. That way we know if something's negative. And then list out any constants. Pause the video if you could do this on your own. Otherwise, you could keep watching. All right, so I'm going to start by bubbling. Same way we've always bubbled. So I want to go through and find my bubbles that don't have any variables. See if you could find those on your own. Pause the video if you need to. All right, so I'm seeing 15, -3. You got to include that negative. And 0.5. It's actually the 3 that we crossed out in the previous problem. So 15, -3, and 0.5. Those are constants. All right, that brings us to term. A term is basically whatever you bubbled. So if you put something in a bubble, that is a term. In this previous problem, we had 1, 2, 3, 4, 5, 6, 7, 8 terms. There's different types of terms. Your term can be a single number, like 4, a single variable, like x, or the product of a number and a variable, like negative 6y. Go ahead and fill out this chart by categorizing where each of these should go. For example, 4 would go into the single number category, x would go into single variable, and negative 6y would go into product. Pause the video and do this whole chart. All right, hopefully you're ready to check answers. So I'm going to go ahead and fill out the rest. See if yours matched with mine. So all of these are terms, and there's 3 different types of terms. Let's look at this meme. Pause, think about it, see if you get it. So they're basically saying, does this x mean 6 times 3, or is it 6x3, which would be like 18x? I don't know. And then here's one more. Some of you are 11, so that works out. So yes, variables change meaning. Someday x will be 8, and another day x will be 5, or even on the same worksheet, it'll have 2 different values. All right, you guys have bared with me. We have 1 page left. I know you might be getting bored, but please and thank you for listening. So here, this is kind of what I was showing you with the coefficients before. How coefficients allow us to take a big string and write it more simply. So for example, on number 1, this one actually doesn't even have a variable. This is just 8 added up a certain number of times. We know that we can write this as 8 times something, however many 8s there are. Pause the video and go ahead and fill that in. All right, hopefully you're ready. I think there's 8 of them. You could also write it like this. For problem 2, they want you to do the opposite. You're going to write out that long string now. Go ahead and do the opposite for problem 2. The star in the middle just means times. So basically, you're going to write something like this. Pause the video. All right. So I'm going to choose to do 9 plus 9 plus 9 plus 9. But if you did 4 plus 4 plus 4 plus 4, etc., 9 times, that's also correct. I'm just taking the easier one to do. Notice how when you write it out like this, you're writing plus signs. So the shortcut way is the multiplication, and the long way is the plus signs. All right, see if you could do number 3. Pause the video, come back when you're ready. All right, you should have gotten 3 times 6 or 6 times 3. It doesn't matter the order. What do you think about number 4? Pause the video and give it a try. And if you're stuck, look at number 5 to help you. All right, so I have to write H 7 times. These mean the same thing. I'm always nervous in my videos that I'll write it 8 times or 6 times. So it should be like that. Go ahead and try 5 and 6. Pause the video and come back. All right, 5J. How many do we have here? Is this 10? I think this is 10U. Sorry if I counted wrong, though. I'm too nervous. I have to check. Okay, I think I see 10. Okay. All right, try number 7. Pause the video. Come back when you're ready to check. Yes, these are the same. 4 times 7 is just a shortened way of writing that. Oops, and actually I made a mistake. How embarrassing for me. I didn't notice. I thought that these were plus signs, and they are not. Feel free to laugh at my humiliation. So they would be the same if it said 7 plus 7 plus 7 plus 7. It does not say that. So really, this goes back to our last unit. This would be 7 to the power of 4. Go ahead and try 8 if you still need to. This would look like this. So we're doing the multiplication signs in the middle when there's an exponent involved. and we're doing the plus signs in the middle back earlier on the page when we were just writing it with a coefficient out in front. All right, number 9 is kind of a goofy problem until you see what it means. Then it's not so bad. So basically, they want you to look back at the problems we just solved. So problems 1 through 8. And they want you to figure out, by looking, which problems have numbers and which problems have variables. So problem 1 only has 8s in it. Those are all numbers. So we would write problem 1 down here because they want us to list out which ones have numerical expressions. Those mean numbers only. And in A, we're going to be listing out the problems that are variable expressions, which means that there are some variables in it. Go ahead and pause and see if you can pick which category each problem belongs in. If you're confused and just kind of staring at the screen, let's see if I could do another one for you. Problem 2 doesn't have any variables. If you're picking up on what you're supposed to do, you could pause and come back when you're done. Problem 3, no variables. Problem 4 does have a variable. So does 5. So does 6. 7 and 8 only have numbers. All right. Try problem 9C. Come back when you're ready. You can pause it. All right, these wouldn't be equations because there's no equal sign. That is it. Thank you so much for watching this long video. I appreciate it.